Storage. That's right. You are looking at storage matters. That's what's happening here. And when we're talking about storage and distributed storage, first and foremost, I guess we should talk about, like, what storage versus other forms of storage. So I guess maybe I'll even ask Jordan the question. Like, Jordan, what would you say the difference between normal storage versus like distributed storage is, since it's not all the same?
Well, normal storage is storage that is only accessible from a single system, essentially, or is managed by a single system, whereas distributed storage would be basically accessible to multiple store systems, like in a cloud sort of arrangement or a um, cluster sort of arrangement. So if you have a cluster of pies or servers or whatever it is, you need to have basically a cluster of storage that cluster of servers is able to talk to and like utilize. So I don't know. That's the best of my understanding.
And that's a good way to put it. So what I started doing is, because you mentioned pies, and of course, storage doesn't have to be on pies. It could be on anything, really. So maybe I'll even just change that and say system, or, I don't know, computer. But either way, you get the point across. So system, we'll take a look at another system. So let's say that we have a system. Of course, as Jordan was talking about, like, inevitably we're going to have like storage, right? And so if we just talk about storage in general, we have different types of storage. So if we have just storage, that could be a hard drive, it could be a RAID of some sort, it could be a lot of things, really. But what if we were instead expanding that out to be like, okay, so storage versus distributed storage? So if we take a look at, like, kind of what Jordan was talking about, or exactly what Jordan was talking about, systems in general need to have storage to run. So if you have a laptop or you have a desktop, it doesn't matter what kind of system you're running, and you want to have an operating system. If you're watching this right now, you're watching this stream from a hard drive of some sort. You're watching from some storage, right? And if we were to just say, hey, I need some storage, that's a lot more straightforward from talking about distributed storage, because every system has to have some form of storage. You could think of storage as a hard drive or something of the sort. And so let's just go ahead and illustrate this real quick with this little diagram of things. So if we're taking a look at different systems and they have storage, let's say that we then had different systems that we wanted to make into like one supercomputer, which is a little different, right? So kind of like as Jordan was talking about, where you might have multiple things working together, or nodes, or however have you. Let's say that we wanted to say, I want all of these systems to basically be able to communicate, where, on the storage, if they have an operating system, they're all, running their own version of some form of storage. But what if we wanted something that worked across all systems, that's then available to all systems, and this is when we start to get into cloud, right? And so we could think of, where would someone use distributed storage? Something that's like cloud architectures, things like that. And, there are other reasons why we might use this distributed storage. We might use it for redundancy, or for backups, or for who knows what kind of solution we're using. But if we wanted to then say, hey, I want to have 3 systems, which is effectively, we could just call that like a supercomputer. We wanted to get into supercomputing. Then we might want to have some form of storage that's available to everything. And so bam, that is where we're like, okay, so how about we have something that, let's say that all these systems run together and we want to have a way to where there's, say, like a drive or some sort of volume that's available on everything or to everything without necessarily having to have separate drives. And whether or not we want to have, say, like a bunch of extra hard drives that all talk together, because, there are different ways to go about creating distributed storage. We could have something where it's just like every single one of these systems is running a little hard drive that's like extra or something along those lines. And then maybe all of these volumes tie together as just like one single hard drive. It's a really complicated, kind of confusing, convoluted concept. So let me just show you like an actual idea of like real implementation of distributed storage. So if we take a look at this sandbox that I have running here. In this sandbox, let's say that you do have three systems, right? So we'd call those three nodes in cloud or in computing land, whatever we want to call that. And let's say that those systems then had different amounts of storage. So let's say that, one of them maybe had 500 gigabytes of storage, and then one had, say, like 250 gigabytes of storage, and another one had another, however much. And then together, when they talk, they end up with a little more storage together as just like all these systems with a volume, one volume running from three nodes. And that's kind of this whole idea here. So, what this is called distributed storage. Now, every single one of the systems here, like when we're talking about like running, and let me move Jordan's face a little bit so you can see what I mean by these three nodes here. So if we have these three nodes, let's say that we wanted them to be able to share data, share volume, share whatever they're doing. These nodes all share the storage. So, if there's a file that's only available on one system that needs to be available on another system for an application or something that you're hosting, especially if you're a developer, that starts to get a little more important. If you're not a developer, if you're not trying to do development types of things, then this is probably not the type of thing that you're probably going to be spending a whole lot of time taking a look at. But for those who do need to actually make sure that data is available in places, that's when we're talking about what is distributed storage, that's what it is. That's when we have, multiple systems working together as one, where they all have their own storage, but then we're saying, hey, I want to use software to make them sort of share and create sort of like one giant virtual volume that all of these systems use together. So that's something that is, that's something that's important for hosting. And let's get into why does this matter? Because let's start kind of talking about sort of, let's go back in time a little bit, pre-cloud. So let's say pre-cloud times. If you're trying to work in computer technologies these days, things are a little different, depending on where you work in the space. If you're working with companies who work with newer technologies, they're going to work with a lot of these technologies like Kubernetes, Docker, and things like that. But this will be a good question for Jordan. So Jordan, what would you say, before cloud and all those good things, like how would people generally want to think about like storage? Or I guess, how does storage work when we're talking about like before having 100 nodes working together as one? And I'll illustrate it.
So you're talking about just like on a single system,
yeah,
where you basically are going to have some sort of hard disk that's storing all your applications and the important, like your operating system. Everything's there, and it's basically generally going to be on a single drive, unless you were running some sort of RAID array, which back in the day when you were running spinning hard drives, they were really slow. It was really nice to have like some sort of RAID 0 array where you're striping them. And so each hard drive is getting part of the data, and that makes them multiple hard drives able to work together as a single drive and be much faster than they would be as a single drive. The other thing you could do with a RAID is generally have more redundancy in your storage, where you set up like a RAID 1 or RAID 5 or 6 or 1+0 or whatever it is, that has multiple copies of the data on multiple sets of hard drives. But again, you only have a single system that's managing all of that data and is managing that RAID array. So it's not like multiple systems, but
Yeah, exactly. More or less, everything's just in one place.
Hi.
And it really just kind of comes down to just things were a lot more straightforward when we weren't getting into working with multiple systems. And so all of a sudden nowadays, distributed computing is something that's not mandatory and, for companies to work with these days necessarily. It really depends on what companies are trying to accomplish. But when companies want to start getting into what's called distributed computing, that's a lot different because right here, like when we're working with a single system, just as Jordan was talking about, we might be talking about these systems, they might be attached to, say, what's called a RAID, where maybe we're using multiple hard drives. Maybe we're using a hard drive, but just on that one disk, we're running all of our applications, and if we're running operating systems, maybe we are running like a RAID, or maybe we're running like something that works with multiple volumes or something along those lines. So maybe we even have multiple operating systems that are attached to a single system because there's something called, for those who are familiar with like hypervisors, there's type 1 and type 2 hypervisors. And so we might still have like, say, a single system, and then in that one single system, we might have multiple little computing units. So we might have virtual machines. We might have one business system that has a virtual machine or something along those lines that does a lot of things, like running applications or running a different operating system from the host operating system. Or maybe we even have, 2 or even 3 or however many virtual machines that we have. And so then, within our virtual machines, generally speaking in the past, then what companies would do is they would just put, make sure that there's a drive or a drive volume configuration that's attached to the primary system that would then allow these other systems or other applications running in either the systems or in the single system, whatever that may be, because if we have a single system here at virtual machines, then it no longer is one single system. This is now 1, 2, 3, 4 systems, and they might all have applications running on top of them. So this is kind of what we've come from conventionally for development standards when we're trying to build things, grow at things. But let's say that now we're entering into this new like cloud distributed computing land, right? So I'll say cloud.
Well, and one thing I think might be worth mentioning too, right before you move on, is just that when you had multiple virtual machines accessing that volume, each one of those machines was going to basically carve out a chunk of that volume, right?
Yeah, that's exactly right. And so, actually, that's a good thing to outline is, let me go back. So, like, if we take a look at this, this is actually really spot on, is regardless of what volume architecture we're using, whether it's something called a SAN or a NAS or a RAID, one of the things that's going on here is all of these different virtual machines are generally using one set of volumes. Now, companies sometimes will go so far as to say, like, this one single system, maybe it has enough interfaces to add like inputs for additional drives and things like that, so people might expand inputs, but nonetheless we're kind of restricted to like whatever this system's hardware inputs and outputs are.
Sure.
And so it's like the minute we want to expand beyond whatever that system's inputs and outputs are, all of a sudden things get tremendously more complicated. And so then that brings us into this whole concept of like cloud distributed computing. And then there's something, let me pull something up real quick. There's something called the cloud native landscape that I'd like to kind of bring up here, which anyone can pull this up if they'd like. You can look in the top right corner of my screen where I'm highlighting and circling my mouse. You can look at that URL and you can type it in and go to it. I could put the link in my YouTube video, and at some point when I get the time I might do that. These days, I don't spend as much time on the marketing bits and the little things like that. I spend most of my time engineering. So I spend most of my time with Kubernetes, Docker, all that good stuff. So apologies if things take a while to get updated on the YouTube channels and things like that. But I care more about working with Jordan to get the information out, because at least you can watch these even if you can't go and scroll down the description, which it's a lot easier for us to get this information out this way. So if you've ever heard of the cloud native landscape, and if you've never heard of it, check it out. Then something that it does is it outlines these ideas, different types of things that you can explore to try to figure out, how can you start getting into, cloud computing, different types of tools. And, notice the longer I've been getting into this stuff, I've been starting to fade, because if you look at my green screening, I'm starting to turn into somewhat of a ghost. But anyways, that's besides the point. So if I look at, let's see, there's a lot in here. There's so much. We could look at where it says cloud native storage. And, if I just zoom in on this, then we can get a much larger glance at, what are we talking about with this whole idea of cloud native storage? Because if we're moving beyond the hard drive, then we want to know, what all does that entail? If we're moving beyond the hard drive, then maybe we want some soda from Soda Foundation. Well, that's besides the point, because distributed storage is where we can have, just like as I was illustrating earlier, we can have multiple systems that are sharing storage volumes together, and there are a number of benefits beyond just having more storage available to a computing environment. There's a lot more to it, because it has to do with, all of a sudden we can expand bandwidth. We can make a computing layer distributed, where it might have, say, like a volume that lives in multiple physical locations around the globe. There might be like part of a volume in one country, in Europe, one volume in Asia, one in South America somewhere, one in North America somewhere. Who knows, whatever we want to do with distributed volumes, there's some dynamic possibilities and options where you're not going to run everything necessarily in distributed storage, because sometimes having local storage matters, especially for like speed and availability of certain things. Yes, I'm sure. But when we're just talking about sheer availability, or we could even call it high availability for those who've heard of high availability, then there's a benefit and a value to making sure that, like, what if there is a volume that's used for an application that runs, say, like for example, if we do go over to LinkedIn, or we do go over to Facebook, or we do like this Jamboard right here. This Jamboard is probably running on top of a supercomputing environment that leverages distributed computing of some sort. And that distributed computing is probably managed and leveraged through Kubernetes. And the one that I was showing, and I was showing Longhorn, so if I click on this again, and anyone wants to take another glance at that, where we're showing, here we have 3 nodes that are sharing volumes. Their total volume size when they're striped with their shared volume is a little over a terabyte, and then we have one volume running on top of this set of shared storage. If we go back over to the cloud native landscape, you can see there's a lot more than just, say, like Longhorn or however have you. It's just that Longhorn so happens to be the one that I'm using, but there's a lot. You can see there's one called Ceph that's pretty popular. Rook technically works with this thing called Ceph, and then there's one called Gluster, Minio or Min.io, I guess, or OpenEBS. There's a bunch of these different cloud storage solutions, and so if we go back, cloud distributed computing. Let's say that we are trying to host anything. Like, we could just say that we're trying to host WordPress. So we'll just illustrate that. WordPress. And actually, I'll just say a WordPress site. And so I guess this is a good question for Jordan. So I guess, Jordan, if you're running, say, a WordPress site, And let's say that we want that WordPress site to not just like go down, I guess. If we build WordPress sites on top of a single volume, I guess what challenges do we run into running a WordPress site, say, like on a single server? So maybe I'll draw out two illustrations while you kind of explain that. So it's like if we have a single server and something happens to that single server, what happens to our WordPress site?
Sure. I mean, I think there's a number of challenges you can run into. I mean, first of all, if your server crashes, obviously there's no data for anybody to access. So,
That's right.
uh, and even if you're running some sort of, distributed computing, it doesn't matter if it's all running off of a single volume and that volume disappears. So, I mean, I guess that's one challenge. And then obviously, like if there's too much traffic to a website for that volume to handle, you could run into website slowdowns or website crashes. So, I mean, that's another good reason to have distributed storage. So, I mean, give
Totally.
you more bandwidth essentially to said storage. Um, Trying to think of what other some challenges there would be just off the top of my head.
What if like a drive fails to recover?
Oh yeah, sure. I mean, yeah, if you lose a drive, I mean, it's essentially the same as your computer crashing, right? Except for it's more fatal and difficult to recover from.
Oh, totally.
If you lose that drive, you just like lose your website. So,
Mm-hmm.
and nobody can access it, obviously. So, yeah, I don't know. Having single points of failure is always very dangerous when it comes to web development.
That's a good way to put it. Let me just put single point of failure on there. So like that's a good way to put that. Obviously, the further away you can get from having a single point of failure, the better. And it's not to say that, well, because there's different ways to get multiple volumes. You could use multiple systems in different ways, but
Sure.
still, when you're having a system that doesn't have some shared form of storage, then at least for that one system's volume, you're in a scenario where you are actually running with a single point of failure. So
Mhm.
if we were to then outline, um, cluster. Well, let's go even further, and we're going to call it a high availability cluster. Because if you were to create a distributed storage volume on a single system, we still run into the same things. But if we introduce something called high availability, this is where we're talking about having multiple systems that if one system goes down, then another system will sort of try to take over what's going
Mhm.
on. And so, this kind of counteracts a lot of what Jordan was talking about, where immediately right here, where, too much traffic can come at crashes or throttling or slowdowns, things like that. There are ways to expand bandwidth. And so you can find ways to accommodate more traffic just because, when you're working with distributed computing, and let's say that you're working with, let's say that you have 5 systems that can transfer data to drives at 1 GB or however have you, and then each of them all have their own drive. There might be some like network overhead for all these systems to communicate and all that good stuff. But with all these systems, that bandwidth for like a whole gigabyte on every single system suddenly being available, where say like a single system, it might have a 1 GB connection speed,
Mhm.
I guess, interface or whatever. Uh, all of a sudden, like you can receive more than just whatever the input limit on that one single system is by spreading out your compute and spreading out your storage and distributing it and all that good stuff. And then the other thing is, if you have 5 systems, two of your drives have to crash in order to. No, how do I put this? I'll just write this down a little bit because this is where it gets confusing. Um, if you have 3 distributed drives at least, so if let's say that you have 3 systems instead of one single system, and one goes down, you can configure it to where basically like, oh, that one system went down, and there are ways to do it with 2 systems, but 3 tends to work better and more universally. If you can get 3 systems that have, shared data for distributed storage. But let's say one goes down, then the whole instance stays up because, you can have something work to keep everything going down. And then let's say that you start to add more nodes. Then if you have 5 systems sharing volumes, then you can have 2 system failures and everything will just kind of keep running and it won't go down, and that storage will still be accessible and it'll still work and it'll still do what you need it to do. It'll still host the apps you're trying to host. And then, you could scale that up if you want. We could push that up to 7 and 3. And so that's like kind of the general math. It's not the most complicated math, but how do I write this? So like multiple points of failure.
Gives you redundancy.
Yeah, there we go. Redundancy. That's a better word. So then all of a sudden we get redundancy where it's okay if something goes down. Like something goes down, like, okay, who cares? Something went down. That's nice. Then at least we have the time to respond and react, and it's not mission critical, and it's not like the end of the world, and it's not crazy. And then finally that brings us to kind of following along with that is, if we do run into like the potential probability for like a drive getting corrupted or something along those lines, the redundancy is just a factor that comes in there where we get more error checking and more validation.
It's probably worth keeping in mind too that, hard drives and storage are one of the most prone pieces of computer systems to failure.
Yeah, that's a very good thing to outline, and we can even just say, I'll just outline that. Or I guess most prone to failure. But anyways, I just wrote on here, drives are one of the most likely computing parts to fail. They're just incredibly prone to failure. It's very true. And, if you're just running with one drive, you're kind of playing with fire. And for anyone who has spent a lot of time in like disaster recovery land, ideally, if you have a file that you want to make sure is truly backed up, don't just make sure it's in one location. Don't make sure it's in 2 locations. You might be like, oh, great, I have this file in a second location. If it's really important to you, you should have it in at least 3 locations instead of just 2. There are reasons for that. And so as a standard practice, you'll find in the general IT space and whatnot, you'll find that it's pretty common to say if you want to have proper disaster recovery, proper HA, all that good stuff, then you want to have, at least 3 systems. And then that's going to make quite a bit of a difference.
And at least one of those should be offsite somewhere.
Yes.
They should be in literally different locations physically.
Yes.
At least one of them should be away from the other 2. So.
It's a very good point. And so, yeah, you don't just want to have 3 backups. You want to have at least one of those backups somewhere else too. So 100%. So, if you have a remote backup and then one local backup, maybe make at least 1 second local backup. If you have 2 local backups where you're just like, oh yeah, we have the backup server and then all of our workstations, find another place to send to back up your backup server. Things like that. Very good insight. So, those are a lot of reasons why we might have servers. And then the other thing that or not servers, but distributed computing. But let's say that we're doing, hosting applications. Let's say that you're a developer and you're trying to host applications, and not only are you trying to make those applications less prone to going down, but there's something else that comes into play where we want the data for our applications to be available places. And so, the way that I could put that, how would I put that? So, data availability matters. And so when we're doing like cloud computing and things like that, one thing that maybe a lot of folks kind of take for granted is, if you're going to a little app on your phone and you're just like flipping things around and clicking on things, you're not necessarily thinking about what is under the hood. Because under the hood of like, you know, every phone app that you're using and you're, doing whatever little things that you're doing or, however have you, or, you're sitting here trying to get your Windows apps to do whatever you want those Windows apps to do, at some point, you want to make sure that, like, as the user, that when you click on the app and then log into your app, that your stuff is there. And when we're talking about like cloud apps and things like that, then one thing that distributed storage makes easier is making data more available, especially for like lots of users or lots of, where you can just move data around. Like you can make data available in other locations. And so we can say easily just like location A is what I'm going to, I guess, outline here is this example. And then we'll just say that we have 3 locations. So we'll say location B, and we'll get into a location C. One interesting thing that we can do with all of this, when we start having all of these different locations, is normally you have to, move data around and maybe you have to migrate data, or maybe you have to have data all centrally located in one site, and maybe this one site does have multiple nodes, right? We might have multiple nodes in site A. And we may or may not have multiple nodes in site B or site C. But something else that we can do is we can then make this data that's available over here where, what if the entire site goes down, right? Because that's possible too. We could have a situation where like this entire thing is just like toast. And it's like, all right, so, we had location A and it just went offline. All right, well, not a big deal. The data is also available at location B. And for users, let's say that you're a user. Users look like this. We'll just say user apps and data. So users using their apps and the data for those apps, right? Especially if you're a developer, this matters more. If you're just a consumer, this probably doesn't matter to you. This stuff can just continue to feel like voodoo, magic, or whatever you want to call it. But someone actually has to make this stuff possible. And for those who are wanting to be the people who make those things possible, then it's important to say, okay, so we can make it to where, okay, location A, that has data. And then location B, that has some data. They all share the same volume. And then, bam, let's say that all these locations right here share data. And then going back to this whole idea, we might take, like one of these goes offline. Let's say that there's an outage in the area. Great, who cares? The user will never know. So far as the user's concerned, maybe there's a blip where something gets slow for a second. Or maybe during the process where everything fails over, to move their session or connect their data to a different node, maybe there's like a little blip or a little delay or something along those lines. But ultimately, all of a sudden, like this data is available to where, even if there's an outage, this data is available somewhere else. Or, even if it might be faster to send this data from one location than another location, where then we can start to optimize and be like, okay, so now users can get a better experience because all of a sudden data is available in all these different locations. So that's a whole lot of, of what's going on with storage. I guess, Jordan, do you have any thoughts about, like, what are some other things that make having distributed storage important? Because we've covered quite a bit at this point. We covered quite a bit pretty fast too.
Nothing else that really came to my mind. I mean, it's mostly just having that high availability so that your users don't experience any outages if you lose any servers at any of those locations, right? I mean,
Yeah.
I think that's the biggest point.
And it's easier to establish this stuff than folks might think. Especially for a newer company who doesn't have any resources yet. I'm coming to this weird realization that, like, the newer a company is right now in 2020, the new technologies are so much more affordable that if you haven't done a whole lot just yet, you can go crazy with all kinds of stuff you can do.
Yeah.
Because I even, like, I work with a pretty young company, and there's just so much you can do with young companies. And if someone else is running a young company, or if you're starting a company and things like that, like stuff that you used to have like SANs or Drobos or like big like NAS environments, or all these other means of trying to make data available, you can have multiple teammates who are admins who, all of them, maybe all of this is just like admins at a small company. Like, hey, yeah, we're the primary developers and admins. So maybe it's like there's a developer's location there, there's an admin's location there. And it's like if it's a brand new, company, you're trying to get something off the ground for the very first time, and we're already kind of in a weird era where offices, it's like you can replace the cost of an office with just internet speed and people's locations, and pay less than paying for an office. So instead of being like, oh man, we got to come up with an office, well, now you can just distribute the office. So that's the whole idea here, is all of a sudden, like, distributed storage also lets us distribute the concept of on-prem. Distributed computing lets us distribute the concept of on-prem. And so you don't need to have a location when we're talking about distributed computing. And if you have a distributed server, this little design right here, if I draw a little more, this little design right here might be a single server, literally. So we might just put a little line here and say, so, and this would be, and this goes back to the whole idea of distributed computing. I guess you could call it one cloud or one cloud server, whatever you want to call it. But ultimately, like I said, this could be someone's home. This could be, you could have 3 developers who got together. One's more of an admin, one's more of a developer, one's more of a person who knows what, and they all develop stuff. Maybe one's really good at like UI, UX, maybe one's really good at like operating system, maybe one's really good at something else. And let's say that they all wanted to create some big crazy cool cloud app, and they could start something like that for like $1,000 nowadays, which is crazy to me. Like $1,000 just for the infrastructure, and then just instead of getting an office, just get everyone like really good internet. Be like, let's give you really good internet, let's give you really good internet, and let's give you really good internet. And then bam, now you have the bandwidth from 3 different locations, and then you, depending on some people's connectivity situations, maybe that might require relocating, but everyone's got to pay rent and stuff like that anyways. So if someone's really serious about wanting to, resituate their circumstances for starting like a business, you can make where you move as a home an alternative to, once again, you don't need to have an office. You could just optimize where people live, optimize the network connectivity of where your founders live, things like that. And I'm especially talking to founders and people who are starting like fresh companies. You haven't even been in business for 2 years yet. You haven't been in business for 2 years yet. Sky's the limit these days, is because it's really expensive to go backwards in time with your development. Yep. But it's really easy to go forward with like the newer things, and stuff has just come down so much in cost that it's like mind blowing.
There's been such a proliferation of the tools too. There's just so many different ways you can do this versus 5-10 years ago.
Oh
There
yeah,
was very limited,
it's so true.
methods for this.
So I guess ultimately that kind of covers the whole general idea for like cloud storage. So um, yeah, for anyone who is getting new to new to this stuff and is just kind of wondering like how can I start getting into cloud, some industries, because I guess I'll address a few questions that I get like on LinkedIn and in the socials and things like that before we wrap up this stream, because I get so many questions all the time, and sometimes I don't stop to answer them. So I know most people probably aren't, who have the questions probably aren't listening all the way to the end of this, because the people asking these questions sometimes it's a little advanced for some of these folks. But I get a lot of questions for people trying to figure out like how in the world do I get into this space, because this is kind of made for people who are kind of already working in this space and you're trying to like up your game. But I do get folks who've just never worked in, say, tech or cloud or security or whatever you're trying to do. Oh, and I get this question like, how do I, like, what certifications do I get, or how do I get into the space? I've been trying to find different ways to explain this and talk about like what certifications do you get and all these things. Because the one thing I want to be careful from, because a lot of people are like certifications don't matter, and sometimes I'll say things kind of like that, but it's a little like that's like a cop out answer. That's like one of the laziest answers ever. Like, I could just be that person again and just be like certifications don't matter. It's not that certifications don't matter. Certifications are actually outstanding, but it's not the certification itself that's necessarily what makes a certification outstanding. Because let's say that okay, you want to go work for a company. Some companies require Security Plus. Okay, great. So if you want to go work at a company that requires a Security Plus, go get a Security Plus. Great. But beyond that, the real benefit of certifications is they give you like a recommended learning path, which the learning path in a lot of ways is almost more valuable than the certification, because you could try to take, say, like a pen testing certification and never pass it and then go get a pen testing job and then crush it and do an outstanding job crushing it at a job. If, like, let's say that maybe you were trying to learn, you were new to the stuff, the pen testing certification was hard. Even if you fail a pen testing test a bunch of times, you're learning, because you're learning terms, you're learning jargon, you're learning like what are people looking for, what are the concepts that people are talking about in this general industry or this general space. But one thing that I want to tell people to kind of steer clear of worrying about or getting too concerned about is it's not the certification that gets you the job. It's not the certification that gets you the job. Certifications are valuable, but the minute I say things like that, usually people are like, oh, certifications don't matter. No, I'm not saying that certifications don't matter just by saying that the certifications don't get you a job. Certifications contain learning. They contain like dedicated paths for how you can like figure out things, like the study process, and sometimes like some certifications can open doors, that you wouldn't have opened without, say, certain certifications. But, then I get the question of like, well, then what does matter? If certifications aren't what I should be working on for getting these things, once again, work on certifications, they're fine. But the thing that really gets you somewhere is actually learning how to do the stuff. And you can learn how to do stuff through certification, sure, but what you really learn is like, I like this cloud native landscape, interactive landscape, because you can Google what these are and you can install these in a VM or on a Raspberry Pi and just start learning how to use any of these little applications. And if you learn how to use any of these in any of these little sections, you can just sit there and be like, all right, I want to be a master of databases, right? Most people on the planet who know things about databases either went to school for them or work with it or things like that. But what if you're a person who so happens to know all the stuff about like most of these little databases in here? Bam, you're going to get a job. Because like, let's say that you spend time learning the difference between this database and that database, and you can articulate the difference between MariaDB and which is technically a MySQL database, and you also know what a MySQL database is, and maybe you also know the difference between that and the Cassandra database. Maybe why would you use Redis over Yugabyte? Being able to answer these little types of questions, these are things that you can learn at home on your own hardware, on your own infrastructure, on your own things. And like we're talking about distributed storage, you could sit here and you could build out a whole bunch of VMs, or you could go get a bunch of Raspberry Pis, and you can literally build distributed computing and build some distributed storage in your own home and set up disaster recovery for your entire family and learn. If you were to just create disaster recovery and create like a NAS or a home backup or something that hosts all of your games or hosts all of your movies, that's a professional skill. You're more likely to get a job to, like, you go into an interview and they're like, so what do you know? You're like, oh, well, I made this app, and then you just literally show them on your phone. Bam, look, show them the whole app. You're like, oh yeah, I built this into it. I built this, and check it out. Like, so I got redundant storage, and da 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 da. They're gonna hire you in 5 seconds. No, maybe not 5 seconds flat. They're gonna want to talk to you, and they're gonna want to see if they like you as a person. They want to see if they would want to be friends with you and things like that. But that's gonna be 1,000 times more impactful than being like, well, I have this certification that a million people also have.
So, so you need to get the certification and also figure out how the certification really applies to what you're doing professionally.
Mm-hmm.
And it's also good to like build out those skills. Don't just like leave it where the certification kind of ends things.
Yeah, 100%. And for those who are, because one thing is, if you can get the certification too and get the best of every world, that's the best. And then for those who, I don't want those who struggle, because I used to struggle with certification. One time, my first certification, like the big one that I really needed, I think I failed it like 5 times. And this is way back when this is like, at this point, this is over 10 years ago. But, over 10 years ago, I'm like trying to get my very first certification, and I failed the first one like 5 times. And I had the job already, and I was working already, and anyone can do that. You can get the certification after you already have a job too. So one thing I would also say is, if you are struggling to get a certification that you really want, and you're like, oh, I'm trying to master these concepts, I'm trying to do this stuff, if you've failed a certification that you're trying to get even like 2 or 3 times, try to go get a job for the certification you're trying to get, and then go back and try to get that certification after doing it professionally. I will say that a lot of certifications are also much easier to get after you've even gotten a job. And so I would even say, like, certifications are great to, like, you don't know what you don't know. And if you start studying for a certification, you'll know what you don't know, and you can start studying. So you'll be like, oh, I'm trying to get a certification on distributed computing, and maybe you didn't know anything about cloud storage. Well, great. Start installing it and start building it. And the certification helped you figure out what you don't know. Because otherwise, without something to kind of help you figure that out, is you don't know what you don't know. And you could, just Google random things randomly. You could just follow random YouTubers like me, because I am technically one of those random YouTubers, I guess, in LinkedIn people or whatever. But what I'm trying to do is I'm trying to direct you toward things that businesses have to follow for like standardized purposes, where like regulation says that they have to have these things and stuff like that, where it's like beyond me. I'm not the one who came up with cloud native. I'm not the one who came up with storage. I'm not the one who came up with any of these things. So try to look at some of the official sources. So anyways, I wanted to touch on that, because I get these questions like, well, the certification is not what gets you the job. Important still. Yes, don't run around saying certifications don't matter, because I see that so much. But still, practice. Get your hands dirty. Touch the stuff. Install some things. Like, build something. I guess, like, Jordan, like, you started building stuff a long time ago. Like, when you first started working with, like, storage, I guess, what were some of the early lessons that you learned just from, like, even if it's just like, oh, this hard drive died, or like, what it looks like to see what a hard drive looks like when it's dying and you're trying to, like, save data or something. Like, what were some of the first things that you caught just from tinkering?
Well, I mean, I'm trying to think. One of the first things that I feel like I really kind of had to figure out back when I first started building computers was how RAIDs work, just because of how slow that the spinning drives used to be back in the day. Like, uh, you really needed multiple drives to get, the full performance out of the machine. I don't know if I'm really answering your question, but
Oh, totally.
uh, yeah, I don't know. I mean, and the thing is with tinkering that anything you learn is valuable. So even if it doesn't seem like it, it's amazing how little bits of knowledge will come back to help you later in the future. Um, I
Oh,
think
totally.
another interesting thing to talk about with storage is just how much things have changed since we, kind of got off of spinning Rust, because solid state drives have made such a huge difference with the, you know, vastly improved read and write rates, particularly random read and writes, because most of what you do
Totally.
on a computer, you're going to be grabbing random bits of data, not necessarily huge blocks, right? When you're opening a web browser and like surfing the web, you're not necessarily reading tons of data off your hard drive. Um, and so having a drive that can actually really quickly address data in different parts of the drive is huge, and it's made a huge difference in the last 10 years. But anyway, I think I digress.
Yeah, and that's all good stuff. And so I just kind of noted what you're talking about and outline it here in these little tiles. It's like, just tinkering with drives. It's like you learned how RAIDs work. You learned how to work with different formats of drives in the process. You learned how quickly like these technologies change, which that's a lot of insight when it's just like, okay, so you saw what drives looked like in 2012, even 2000, I don't know, 2008, whatever, like long time ago. And
Sure.
then all of a sudden you see what drives look like now, and then what are the performance differences, like how far have things come, and then like what are read and writes, because some people don't even know like the concept of like a read and a write, and they're like, oh, read and a write, what does
Sure.
that mean, what is that, and then how does data even move in the first place. And these are really like fundamental concepts that you could spend forever trying to figure these things out, or try to get hired at a job and you're trying to like articulate these things to people when you really have no clue what you're talking about. But you can know what you're talking about by just going to the garage, and yeah, there you go. Let's go to your garage. No, I don't know, not everyone has a garage, but I guess the whole idea is like you can just go home and set up some stuff of your own, and it's much more affordable these days. If you're sitting there thinking like, well, I can't afford these things. Well, a Raspberry Pi, you can get a Raspberry Pi for like $60. We could go to, I don't know, say buy Raspberry Pi on Google, and we could go over to shopping, I guess. I don't know. You could go to Amazon, you can go anywhere. And these prices are not making anyone homeless. These prices are so low that if you're trying to learn this stuff and your excuse is I can't afford it, a Raspberry Pi Zero is enough to start learning the basics. And this thing costs right here. You could get this from Adafruit Industries for, well, $5 plus $15 shipping. It's like $20. I'm sure it's probably like $5 from somewhere else though. But still, $20 for a computer to start learning all. If you can afford $20, you can start learning this stuff, you know. And then maybe you might need to get a few cables, or maybe you want to get something that's got a lot of stuff kind of already in there with it, with a little book and a guide. There's like $114 there for more than just a system. $35 here for, a 2 GB Raspberry Pi 4 that you can start learning on, start building on, learn how to make some distributed storage. Maybe you're like, well, I can't afford to learn how to build distributed storage because I can't buy multiple computers. These things are affordable.
Sure. Well, and I mean, if you want an alternative to a Raspberry Pi, because
Yeah, there's
I mean,
alternatives.
yeah, I mean, you can always, if you want something that maybe looks more familiar to you, for instance,
Oh, sure.
there's, you know, a whole market of used laptops and used desktops, and I think that market's probably slim right now after all of the stuff that's been going on the last year, but it's still,
So
you
true.
can find cheap laptops for like $100 or $200 that are
Oh,
used that you
yeah.
can start playing with and just tearing apart, so and
Absolutely.
you don't have to feel so bad if something breaks, then it's not a big deal. um and it gives you more confidence to tear it apart and play with it, so
Look at that. $94 for a whole server. This
wow.
thing will devour power And look at this. It's barely more powerful than a Raspberry Pi. But
It also is barely more expensive than a Raspberry Pi,
I
right?
know that's wild.
$95?
Yeah, barely more powerful, barely more expensive than a Raspberry Pi for $94, but way bigger. This thing's gonna be like this
Yeah, a lot
big.
more fans running.
But either way, there's just not much of an excuse anymore. I mean, just look at all this stuff. 30, 32 gigabyte Percy, whatever, I don't know, Edge R7. You can get this thing. I mean, this is just eBay. And then, of course, there's like other websites and stuff like that. Like technology has become so much more affordable. I mean, we could go over to like newegg.com. And on Newegg, we could just say, well, here you go right here. This is a tower computer. It's not even a because some people are like, well, I don't want to use a Raspberry Pi.
I don't think that is. I think that's a UPS, isn't it?
Oh, is it? Oh, actually, I think you're right. Oh, it is. It is totally a UPS.
That's a power supply for your computer.
It's tricky. Actually,
Which
yeah,
has a
this
little
is a power
computer
supply.
built into it, obviously, because it's got a digital screen. So
Yeah, that's true. I actually need to get one of these. Speaking of which, I probably won't get this exact model. But anyways, speaking of which, you can learn what a UPS is, and you can configure one and set one up. It gives you backup power. It's like basically battery backup. Now this is a little more expensive, $900. So this might be what some people are thinking, like, oh, but I can't afford a computer. Okay, so maybe you can't afford this computer.
that one, maybe not.
Yeah, but we could come in here and just say, let's see what a low cost, brand new desktop costs these days. Just like looking at the lowest cost, because stuff has come down in price so much. And unless you're getting like top of the market stuff, you can get things that are generally affordable. So like you can get a little desktop right here that's got a little i3
Oh yeah, there you go.
processor, and
You can sort it by price too to see what's real cheap.
that's true. Let's do that. Sort by, it's in here. So view. Is it on?
It's right above
by.
the first result. There you go.
Boom. Oh, of course it
Oh
goes.
my
It's just
gosh.
like parts first.
Bunch of weird stuff.
Motherboard.
Hey, but there's a Lenovo.
We got a Lenovo, brand new, or I don't know if it's brand new. I would imagine it is refurbished. There we go. I mean, it's still a computer. It's got 4 gigs of RAM, so not the most RAM. It's got a decently fast processor and stuff like that, but nonetheless, once again, for $100, you can learn. And there's another one right here. I mean, we could just keep going up.
I was gonna say Dell is also a brand that they always have a ton of those old server
That's true.
looking towers that are really cheap. So
Oh, actually, this one's not too bad at all. Like for $100, look at this. Like this is, it's got 3.6 gigahertz processor speed, and it's got 8 gigabytes of RAM. It's got a case and everything. And then I wonder how many cores it has. Dual core, so that only has 2 cores. But those are some fast cores, and it's only 100. You get 4 of these. You get 4 of these and build a supercomputing cluster with these things.
Nope.
You could build distributed storage with these things, for real. So if all you're trying to do is build distributed storage, shoot, just I don't know, get 2 of these. Bam! They got hard drives in them. There you go. Use up that whole hard drive, put 2 of them together, make it a supercomputer. Bam, boom. And then if you can afford $300, get 3 of them. Hey. And then you can do this stuff right here. And you can store and it has backup solutions in there. You can go and start building like backups with your volumes. You can see how your volumes are doing. You can set up backup schedules. You can do all kinds of stuff. You can sit here and look up, look at how all your volumes are doing. Check out all their statuses. You can even ruin your volumes if you want to. You can come in here and shut one of your nodes down and watch it fall apart. And then it'll come back because that's what high availability is all about. And then you can find out that high availability is pretty awesome. So anyways, I guess the point there being, I do just want to emphasize that is like, My first year trying to get certifications, for real, I'm being honest here, I spent $1,500 failing certifications. Don't do that. Instead, and I have certs now, don't get me wrong, and do I regret getting my certs? No, I think I learned a lot, I got a lot of stuff, but like when you're just getting started and you have no idea what's going on, and you're like, I don't know what that is, and you look at something else and you're like, I don't know what that is either, and then you look at that and you're like, what's that? Like if you're kind of still in that space and you just have no clue, much more affordable than getting certifications, and it'll get you a job, you know, and then make it to where you can like access what you develop on your phone, and you can go into an interview and be like, hey interviewer, this is a technical interview, right? Well, let me just show you, let me just show you some shared volume that I made, and you can go in there and like show them straight on your phone and be like, yeah, so check this out. And you can talk about a technical interview that's going to win. Who's going to have a better technical interview? The person who's like, they ask a question that maybe the person knows a lot, but they ask the question that the person doesn't know the answer to, and they're like, and then they have no portfolio, so they're like, I have no way to prove that I know anything, and you're just like, how am I going to prove to this person a thing? Or you could be the person who has a portfolio and is like, well, you know, maybe that one thing that you asked is a little beyond this thing. Let me try to see if I can answer it. And then maybe if you still can't, like, let me just show you this, what I can do, though. Let me show you. Then you just get your phone out, and you sit there and you be like, come over here. And you be like, check this. You can do this and this, and these features. And you be like, I made this myself. And they'd be like, what? You made that button? You'd be like, yeah. And so, like, that's what people want to hire. And there's a lot of confidence that comes with that, too, because, you know, there's that saying that, like, people hire confidence. How do you get confidence? By actually knowing what you're talking about. How do you actually know what you're talking about? Actually do what you're thinking about trying to do. You can do it before the interview ever happens so that you actually know what you're talking about. It's amazing. You don't need to go to college for that. You can go to college and do this. You can do all of the above. You could go to college, you could get certifications, you can do this, or you can just, if you're just going to choose one, at least just do this much. Just like go build your own things, you know? And you can build a whole career just that way. So anyways, I just wanted to outline that, and I guess now we can probably go ahead and wrap up. But I guess, Jordan, do you have any other thoughts on distributed storage?
I mean, I think that we did a pretty good job introducing it and kind of explaining why it's needed and important. So no, I mean, I think, you know, go out and get some nodes and play with it a little bit. As Nathan was saying, you know, if you're an employer and you have the choice between somebody who has a cert but can't necessarily answer your questions that well or doesn't have good examples of what they've done versus somebody who has no cert but has like examples of what they've done and how to do it, I mean, you kind of know as an employer that, well, we can get the person that's done this stuff the cert, so we don't need to worry about them so much. It's like, but if you have a cert and you can't explain things, that's kind of concerning from an employer's point of view, I think. So yeah, I mean, just play with it. Go out and buy some nodes. It's amazing how affordable it is to do some experimentation with this stuff. So
Totally.